Okay, we're moving on. Chapter 6 is only 2 weeks worth of work. Okay, and so that leaves us about 4 days. In those 4 days, you're gonna have a quiz, and we're gonna look at a lot of AP work. Okay, so you're gonna have kind of this lesson is 2 days. You'll have to take Tuesday to get the homework done. The next one is 3 days. Okay, so it's a little bit more relaxed. You get a lot better at integrals because you get to practice them a lot. Okay. This is applying integrals. Okay, let's say I gave you a rectangle. And now let's call it a square. And it's a square. And then I put this ugly circle inside it because I'm drawing it by hand. The radius is 5, and then I said, hey, what's the area outside the circle inside the square?
Pretty sure problem like you act like it's from the ACT. Yeah.
Pretty sure you're probably right. No, it's not. How would you solve that problem? Okay, yeah. Area of the square minus area of the circle. Okay, right? This would be 10 by 10, right? So 100 minus 45 flat. Right? Okay. Good.
That's all we're doing? Why?
No, we're going to make a calculus. Now, what if I gave you a function f and I gave you a function g? Oh, we're getting there. Yeah, we're getting there. Okay, from, let's call this 1 to 3. What is the area between the two curves?
How does it say the area?
Oh, so you just take the area and take the whole
There you go.
Boom!
Say it again.
So if I'm going to go with f of x, which is basically taking the area of the square, and then g of x is the circle. So you subtract the area of g of x.
It's talking about
No. You missed that whole thing, man. It's like the greatest thing ever.
Yes.
Okay, so it's the same concept. To find this area, f. So if you understand it right now, great. If you don't, the area of f, if you do the integral, it's that whole thing right there, correct? All the way down to the x-axis. And then you subtract out g, you get the red, correct? So this is the procedure for calculating the area between the two curves. Okay. This is the easy way to write it. This is how a lot of people remember it. Top minus bottom. Always top minus bottom. When we get to volume, it's top minus bottom.
volume.
Yes, in a few days when we get to volume. Guess what, Mike? It's top minus bottom. Remember this, okay? This is going to serve you really well. All right. Any issues with that? Anybody want to throw a fit?
Yeah, probably.
Okay. Let's look at some examples.
Wow, that's nice.
Let's find the area of the region. Between the graphs of x squared minus 4x plus 10 and g of x 4x minus x squared over this interval. Which one's on top? Sure. Yeah, which one? That's what you gotta figure out here. Which one's on top so we can do the subtraction properly. What's f at 2? 2's in the middle, right? What's f at 2? 4 minus 8, 4 plus 10, 6. What's g at 2? 8 minus 4. Yep, that is top. Top, bottom. You will run into problems where they cross sometimes. Do these two cross? Ever? No is the answer because we start easy. Is this a parabola? Concave up or down? And this one is concave. Okay, so are they ever going to cross? So there you go. Because f is on top of g. So set your interval up. You don't have to separate them. On the previous page, I separated it. You do not have to separate it. So f of x minus g of x, right? Top minus bottom. This is where people get screwed up a lot. They don't distribute the data. Be careful on calling up what's there. All right, do the subtraction first. X squared minus negative x squared. 2x squareds, negative 4 minus 4, minus 8x, and then 10 is a lower. That'd be what we got with what we got. Can you calculate that interval? Yep. Good practice. See how much practice you're going to get? Every single problem you're going to calculate intervals. Good practice. I encourage you, if you can do it by hand, please do. Don't result in the calculator. We can do the calculator, but if you need it, it's fine. If not, the answer here, if you follow it through, is 16 over 3. What's the integral of x squared? X cubed over 3. That's why we have. Yeah, when you do the integral, you get fractions. Okay, fractions are our friends. Let's try another one. Okay, here's where we might see some intersections. Let's consider that and this. So our possibilities here, that could happen, correct? This could happen. Okay, so we probably should figure out where those intersections are, because I bet you one of those is gonna fall here. You can graph it, find the intersection if it's calculated allowed, right? By hand, how would I calculate the intersection? Yeah, so it equals to each other and solve. Those are getting better at that. So put it all on one side. Oh, factorable is so easy. Five more. Look at that. So they're gonna switch spots. This is what we have. So from -2 to 1, so it'll look like that. And then from 1 to 5, they switch top and bottom. Five is our ending interval. So we only need 2 of these. So I am going to do one integral. I didn't know. I told you why though. On the last one, in the middle, F is bigger than G. And since F is concave up, G is concave down, we know they're not making sense. You need to, you need to make sure. Usually on these are given a picture actually. So I'm giving you less info than you should get. Okay, so what's the top function? From -2 to 1. It's top minus bottom, right? F or G? Don't be wrong. X squared minus 5x minus 7. And we add from 1 to 5. Which one's on top now? G is on top. So you understand there? If they intersect, they're going to change position. So you've got to figure out where that happens. That's a 12. That's an R. Yeah, it's a 12. It's a 12. Why it makes sense that it's a 12. You okay with that?
Okay. Yeah, I don't understand how you do that.
So when you get to this point, we know that some point in here, they're going to switch positions. The question is which is top and bottom. So here, what is F at -2? 4 plus 10 is 14 minus 7 is 7. And G at -2 is -14. F is on top. Now I know they switch positions, so then I can just do it. So you're only testing one spot. So you know F is on top, they switch position because they intersect. unless something funky is happening. This could happen. In that case, you would want to make sure. Does that make sense? Okay, any other questions? I'm gonna avoid the third example because we're running out of time. I'll show it to you tomorrow. And then we'll actually put these, so right now we're doing everything. Based on the x-axis, correct? Tomorrow we're actually gonna put on the y-axis. It'd be right minus left. Do that. This would match what we've done mostly today, like I said, we do one, and then tomorrow, this will match. Very rare to see. Again. We're gonna start with AP five. Yeah. 10 AP problems. Multiple choice. With AP, Alright. We'll have a lot more time in class to work tomorrow. Yeah. Basketball, you can do it. Later days. Oh, that's right. Yeah.
I get that job is neat.
Any other tests that I can pick up?
We'll probably do that. 2:30 we'll meet it. 2:15 we'll meet it. 2:50.
Yeah.
How much time does he give you when you're traveling?
Well,
Like before a game, if your game starts at 7, what time would you arrive?
when we've had JP with us, he's giving them about 2 hours, so 2 hours after. But we don't have JP with us, so.